we do from here on out has a lot of division in it. And what we're going to look at, I think we're just going to break it into just long division today. Then we'll start talking about why synthetic division is your best friend in the whole wide world and what you're going to be able to do with it. Synthetic division is going to allow you to factor. It's going to allow you to factor really, really, really fast. It makes your life so much easier for polynomials than anything. And the second half of 6.5, 6.6, 6.7, and I think maybe, all of those sections all deal with the exact same thing. So I just kind of blend it all together with the synthetic division. But today is the weird anomaly part. It's the long division. Long division of polynomials. It looks really, really weird, but it's something that you have done. For example, when you're doing your long division, what'd you call it?
Does McDonald's sell cheeseburgers?
Does McDonald's sell cheeseburgers? I've never heard that before, but
yes, they do sell cheeseburgers. Delicious.
Not very good for you.
At all.
Oh, that?
How did you do that? That's why we have calculators.
What's that?
But 11 goes into 47.
so what you're doing here,
I know this.
when we're working with long division, you're trying to figure out how many times 11 goes into 4. Well, it doesn't go into 4, but it goes into 47. How many times does 11 go into 47? 4. So we place it above the 7. 4 times 11 is? Subtract it. We get a 3. Drop the 3. Hey, look at that.
33. Drop it.
0.
This is
I've
never seen this in my life.
0 times.
Hold on. When you learned long division, you sometimes had to use zeros and things like
Where
that.
do you get the 3 up top?
I dropped the 3. You dropped the next value.
Up top.
47 minus 44 is 3. Drop the next number, happened to be a 3. So 11 goes. Then you're asking how many times does 11 go into 33? Well, it goes in 3 times. So I put it up here. Subtract out, I get 0. Drop the next number. Does 11 go into 6? No, so you put a 0 here. Subtract 0, and you get a 6. You drop the next value. How many times does 11 go into 60? 5 times. You get 55. Subtract that out and bring down, what was it, 2, I think?
0 or 2. Yep.
Okay. And then 11 goes into 52. How many times? 4.
Sorry, my bad.
And subtract the 44. Oops. And you're left with 8. What do you do with the 8?
E.
Remainder. It's the
We don't put it as an R anymore, but 8 was, we wrote it as a fraction. Remember that?
No.
8 11s.
It's an 8
I don't
11ths.
think you do this.
I just wrote
I've never done this.
I
I haven't done this like this for
I know, it's been a long time.
I've done it ever.
haven't done
We don't, remember, a remainder is just a fractional leftover of what you're dividing by, okay? You guys have all done this, it's just been years. Just division, guys. It wasn't that long ago.
My kindness.
But you do the same thing,
On my calculator, I didn't have that big.
you do the same thing with this. And as I've been saying, more and more, you're not going to be using calculators, even the cheap ones. There are going to be many times you can't use calculators. I have multiple, calculator, non-calculator style parts and things like that. So when we get into polynomial long division, you're basically setting it up the exact same way. The one thing that you have to make sure you have in your polynomials is placeholders if you need them. For example, if I'm looking at, we have 2x cubed minus 7x squared minus 17x minus 3. Is that missing any values and going in descending order?
No.
No. Let's say it didn't have that minus 17x. What would I put there then? 0x, okay? So you have to have, when you're putting everything in that descending order, you got to make sure you have a placeholder in it whether it's what you're dividing it into or what you're dividing it by. Okay? So we write it out. 2x plus 3 into 2x cubed minus 7x squared minus 17x minus 3. And it changes ever so slightly with the way that you set it up. What you're trying to do each time you're using long division with a polynomial is you're trying to eliminate terms. For example, I need to change the 2x into a 2x cubed. What do I multiply it by? If I multiply by 2x squared, I get 4x cubed. So if I want to take a 2x and turn it into a 2x cubed, what do you multiply by? You multiply it by x squared. Now, where do you think I'm going to put that over? If I'm multiplying it by x squared, I'm going to put it above the x squared. Because it's got the same power. You always put it above the same power that you're looking at, okay? Because now watch what happens. I'm going to multiply this by x squared. I get 2x cubed plus 3x squared. Just like with the long division with numbers, you would then subtract. 2x cubed minus 2x cubed is gone. Negative 7 minus 3 is negative 10x squared. And I bring down the next term. And now I want to turn a 2x into a negative 10x squared. So what do you multiply by?
X.
Negative 5x. Because you want it to get to be the exact same term. That way when you subtract it, it goes away. So now you multiply by negative 5x. Distribute negative 5 to here, you get negative 10x squared minus 15x. When you're subtracting, make sure you put subtraction on both parts. I cannot stress the number of times you guys screw up when you don't put it to the second term. You'll add them. I know you. This is what you do. Negative 10 minus negative 10 is gone. Negative 17 minus a 15, negative 15 becomes negative 2x. And what do I do with the last one? Drop down the negative 3. And now how do you turn a 2x into a negative 2x?
Negative.
Multiply it by negative 1. Multiply it through, we have negative 2x minus 3. Subtract it out and you get 0. No remainder. Not always, yeah. You can have remainder, and I'll show you what happens when you have remainder. It's just a fractional amount.
Great.
Okay?
How is that
What's that?
Yes.
X. When I take 2x cubed minus 7x squared minus 17x minus 3, I get x squared minus 5x minus 1.
That's the answer, x squared minus 1x.
Yeah. Basically what that means is that since we have 0 for a remainder, 2x plus 3 is a term that you could factor out of that.
Oh, okay, I got
Which
it.
means it has a 0 at negative 3 halves.
So whenever you have to multiply that by, you put it there?
Yep.
Okay.
All right. This takes a little while to get used to.
I think I understand.
When I go to write this out, I don't want to write out the whole problem like what it's saying right away because they always write it out horizontally. I'm just automatically going to put it in the division thing. So if I'm writing this out, I'm seeing 2x to the fourth, 3x cubed, 5x minus 1. Ladies, what am I missing?
X squared.
An x squared, so what do I put in place?
0x.
0x squared. So as I'm writing it out, I'm putting my placeholders in right away. One thing that you'll start, bless you, one thing that you should start to recognize, if you have a fourth degree polynomial, how many terms should you have? 5. You always have plus 1 terms of your degree. So if you're doing that and you're counting, you'll always be able to figure out what you're missing. Divided by x squared minus 2x plus 2. Now really, all you're really worrying about are the first terms. You're just worrying about the first terms. So what do you multiply x squared by to turn it into a 2x to the 4th?
2x.
2x squared. And where do you think I'm going to place the 2x squared over? Over the x squared. That's the only real trick there is to this, guys. You're going to place it above the power that you're using. And then I distribute that to all three parts. I get 2x to the 4th minus 4x cubed plus 4x squared. And what do I do with all three of those? Subtract. And notice how I'm putting 3 subtraction symbols in. That way I remember to subtract 3 separate occasions. And I bring down the next part. And hopefully you get 7x cubed minus 4x squared plus 5x then. Okay. Now what do you think we're going to multiply by? 7x, very good.
To get that equal to get this to multiply by 7.
Remember, you're always trying to eliminate the front terms. Each time that's all you're asking yourself to do. Then it's just distributive property. Subtract all 3 parts. And I think we get 10x squared minus 9x minus 1. When I bring down the next one. Now what? Move this up some so you guys can see. And I'll bring it back down in a second. Subtract between all the parts. Oops. We have 11x minus 21. You okay with that? That's my remainder. Okay? Now, since that value has a degree lower than what I was dividing by, that's its remainder. So in order to write that out as far as the remainder is concerned, it just looks like this. We have our answer was 2x squared plus 7x plus 10. Was that 11x positive or negative?
Positive.
Positive, so what I'm going to do is just write a plus 11x minus 21 over x squared minus 2x plus 2. And this is my final solution. It just winds up being a fractional amount. Just like we had it earlier when you did long division by 11, you had a remainder of 8. Well, it's 8 elevenths is the fraction amount. And that's really all there is to this. It looks really weird, and it just takes a little bit of getting used to as far as how to set it up and write it out. How to get what?
I'm confused with the adding.
I feel the last part was 19.
When are you supposed to do what?
I get negative 9 minus negative 20 is 11, and then negative 1, it was negative 1, oh, I flipped it, it was negative 1 plus, it was negative 1 minus 20, so it should be negative, oh yeah, it should be negative 19, sorry. It should be positive 19, excuse me, that was a plus.
Got it.
No, it's negative, yeah, I was right.
You're right.
I was right, yeah. It's negative 1 minus 20. Negative 9 minus negative 20? Or is it positive? I lost my sign.
It was
so-
negative.
It did the same change opposite. It was negative 9 minus negative 20.
Alright, oh yes.
Then I did same change opposite. Okay. Got me lost in one part I was on. Okay. Like I said, it just looks weird. It just takes a little getting used to.
It takes a lot of time.
On Wednesday, I'm gonna be gone. Really don't really practice.
Probably should. This is like the next let's go.
Oops, skip.
Oh, I don't know. I don't remember. I know, I haven't even It's too much work.
It doesn't work. All right. Take a second, or 4. Do those 2, please. Let's see. First one here, you got 3x plus 1 into, let's see, 3x cubed plus 2x squared minus 5x plus 1. I got 4 terms, third degree polynomial, all good. 3x turned into 3x cubed.
X squared.
X squared. So you have a 3x cubed plus x squared. Subtract, subtract. 2 minus 1 is 1. Now, to turn a 3x into an x squared, multiply it by
1/3.
1/3
X.
x.
Sweet.
So we got that from her.
Yep.
So 1/3 x, you get x squared plus 1/3 x. Okay. So you subtract it out and you get negative 5 1/3 x
Interesting.
plus 1. So when you multiply, now this is where this one is kind of stinky because of the fraction here. It might be a better idea. Let's see, that would be 16 over 3.
Huh?
Negative 16 over 3.
Wait, is that negative 16?
Yeah. Now I want to turn a 3 into a negative 16 over 3. So let's see, that means I got to multiply it by a 9th, right? So I have 16 over 9. Negative 16 over 9. If I multiply it by
Why not? Why did you give us this one?
27 over 4.
negative 16 over 9, watch what happens. 3 times 16 over 9. That's how it works out. You get 16 over 3. And what was it? Minus 16 over 9. Ooh, this is ugly.
Why
Awesome.
did you do this?
I just
Okay.
left it as that.
It was a
25 over
negative.
9.
Negative 16 over 9 times positive 1 is negative. So then when I subtract everything out, first term goes. 1 minus a negative gives me plus. So I get 1 plus 16 over 9.
25.
So it's 25 over 9. Very good. And that's my remainder part.
Over
Over fraction.
So plus 25 9 over the.
This is not even like a thing. What is this?
Hold on a second.
God, that's ugly looking. That's great. That's fantastic.
Please don't ever give us one like this again.
I got the 3x squared.
I get A. I got up to the x squared minus 5.
Yeah, I got x squared minus
I got
5,
the-
then I just
I got the
Yeah,
1/3
for-
x part.
That's all I got.
Sir.
And I just did 9.
Because that's the remainder. Remember, it's always a fractional amount. Whatever your remainder is, you throw it over what you divide by. Yes, ma'am. I got the 69ths. Remember, I want to get this into the 16/3. Okay, negative. So it's got to be a negative value. So I had to think about, all right, how do I turn 3 over 1 into something over 3? So by multiplying that by 16 over 9, 3 over 9 simplifies to 1/3. And that's where I got that.
How do you know that? I don't know that.
You should know that.
I
You need to know those kind of things.
I
Quick-
was like 3x
Well,
by
it's
16
all right,
over
you're here
9
now.
to get
It's fractions,
16
guys.
over 3.
Fractions don't really go anywhere. They're a lot easier to work with than decimals, so.
I'm not gonna get that.
Okay.
Oh, yep. Just go times 16 over 9.
This is why these things.
Well, remember, guys, complaining about it doesn't help either, so, just trying.
Feel better though.
Trying now.
It makes me feel better though.
True. That's a great answer.
I know.
When you write this one out, we don't need any placeholders. This one should be pretty easy. X in it to turn into an x cubed. I'm sorry, x squared into x cubed is x. Subtract all three parts.
Wouldn't the one be, wouldn't the one be negative?
It was. I
Oh, okay.
did the same change. I did the same change opposite real quick. And what do you do with that little bit?
You put it over x squared.
So we have a minus 1 over x squared plus 3x.
Got it right. That's right.
Yeah, sometimes they're easier than others. You know, for the whole
Easier than others.
That's a good way of putting it.
They are, but it was negative 3 minus negative 2.
Will you give us some marks that come out like correct?
I don't remember.
Just 3 problems.
I have 4 parts, so this one, or 4 terms, so this one we had 3, so we had to put a placeholder in. So let's see here, go to 2x squared, we get, what is that, 4x cubed minus 2x squared. And then a negative 3. Remainder of 5. You guys get a remainder of 5?
Yes.
Good.
Wait, I use subtract. Wait.
That should have been just x, not 2x.
What problem is this?
It is so simple to accidentally write down the wrong number if when you're reading it, guys.
That's the wrong problem.
Oh, duh.
Those don't match.
Oh, negative 3 times negative 1 is positive.
Why is it? The problem on the top, the problem is
Negative.
Oh, not the bottom. Scroll down, I got the answers on the bottom. I said, why is it? They just did.
Why is what?
Why does 7x become positive?
Where? Here? It didn't become positive. It was negative 7x minus negative 1, so that's where
I got it now.
Okay. It's very easy to lose yourself in a sign. And then the last one was what? 8x squared. Wait. Okay, I'll wait.
I don't understand. I probably pumped up all this stuff already.
I'm gonna do this.
What? Why are you squeaking like dolphins again? Can I go to the other one real quick?
Kick it under the door. Under the door.
Hey, what are you talking about?
Must have how many?
Almost like yourself.
Oh no, how do I turn a 2 into a 7?
I don't know.
Addition. Addition. Maybe? No.
So if I want to turn a 2 into a 7, that means I'd have to multiply by something with a 2 in the denominator, right?
Yeah.
What would I put in the
I don't know.
7 over 2?
Oh,
I thought you said denominator 7.
no.
Multiply it by 7 over 2. Because 7 over 2 times 2 is 7.
Oh. Okay, that makes sense.
And then 3 times 7 is 21, so it's minus 21 over 2. Subtract it out, which means now I'm adding the 21 over 2. 21 over 2 plus 1 would be 23 over 2. Because 1 is the same thing as 2 over 2.
What?
Oh.
I didn't understand it.
Yeah.
Yep.
And that gives you
I
the
got it.
remainder.
Must be like
I'm good. I understand.
Yeah, he doesn't annoy me much.
Wait.
So I get the remainder of 23 over 2, and I split that as the fraction.
Okay, because you had two to the thing too.
It's like
I'd rather.
they're like two denominators.
Okay. The trickiest thing is, remember, when you're worried about turning it into fractions to get rid of stuff, whatever this number here, if you notice, is becoming the denominator here. Because that's how math works when you multiply fractions.
They just take the first.
Okay. Let me give you some of these for tonight. In 6.5, we won't pull it up. I forgot what page it is.
So where you at?
So this is on what, 356?
This is long enough.
Go 16 through 26 evens. I think there's like 7 of them. That's my number.
I know.
Are evens in the back?
Nope.
We do
Okay.
One word.
And I'll put them up. I'll put it up here in a second. Take a picture of it, throw it on the board so you guys can look at it. Got a couple minutes to start on it.
Wait, I missed it. Can you explain my things? No. Sorry.
You're doing those.
Page